Good morning, day, or evening, whichever it is. I kind of skirting about to get a video up. I had a little audio problem. We'll see if we can get this done, though. I really want to talk about the what's really week 7. I had to change that, but the content. It's just a matter of when I want to get this in before week 8, so that we can do some of this when we're on the second, third, and fourth of March up there in either Georgia or Oklahoma, wherever you're assigned. So I'm going to go through this module, and it's a step up from just general slope staking. However, it uses all the terms or the foundation that we learned in basic slope staking. While I was sitting here a while ago, I kind of sketched out something that let me see if I can pan to it without messing something up. Uh, oh, this is a little sketch, uh, maybe a familiar looking thing that you in the module you're on, building a cut slope. Well, if you can, where my pencil is, this 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 is the ground. The original ground went all the way across here. So we started this dozer back this way. I tried to make this three-dimensional. And so he made a cut, which would actually turn out to be a slot on his first run. But he's going to move over this far, and he's going to make another cut some right here. And he gradually works himself, but he will move all the way over to where the next catch point is, wherever this is supposed to be. It's just the original ground, and it's going wherever. But he's going to keep gnawing away at it, and it's going to start disappearing as he goes away. But this is all looking under the original ground where he set it. So the first thing he does is he cuts a slot down through here. That's really may be more confusion than helpful. But you can see the notch he made would be this notch right here. And then he would move over, like if it's 2 to 1, he would move over 2 feet, and he would cut again over 2 feet, over 2 feet. I'm sorry, I'm not telling you the truth. He would cut this all the way across to wherever they're not needing the slope. If it was 2 to 1, he'd cut it all the way across at 1 foot deep, just moving over probably half a blade each time. And then he would have, this would be going all the way over, and all this, if you can understand this, if this is helpful, more so than hurtful, I'll be happy. But then he has, as he gets done, he has this original ground, which we're looking at the profile under here, underground, all over. Then he comes back and he moves over here, and he will cut this thing out all the way over till this disappears. All this dirt will be gone, and he will have stepped down to here. This will be all gone. It's not to scale, to about right here. Well, let's just say right here. There's nothing here anymore, and he's a foot down, and none of this dirt is left. So then once he goes all the way with this line till they're not needing a slope, Then he comes back over and he stops a foot short, and 2 foot short, and he cuts down a foot. So this slope keeps disappearing. Now they may work with scrapers doing this. Just come by, take a scrape out, come by, move over, and they're leaving stairs. When we built a fill slope, we were coming up every time. We were going, where's my pen? There it is. We were going up and over, up and over. Here, we're going down and over all the way. This would be up and over all the way back there. Hopefully, I'm not overkilling here. This might help you visualize these things, because when we normally look at a slope, I think we're probably looking at this. When we're kind of illustrating things, this is like you cut a piece of cheese off, I like to say, and here is the slope that we are building. Or if we're building it, it's still going to go up some. If we're building it, we're in process, but if it's built, then we'll be done with stakes and everything. And I wanted you to know that when we're talking about these stakes, we will set all, if it's a fill slope, we will set all the cuts, the toe stakes first down here on this, maybe you can call it original ground, but it's prepared surface. And then we'll start, coming in like this and building up. And these will go all over. These will be lifts. And then you will take the stairs out of it. I think I'll quit there because I feel like I'm not a good enough artist to really illustrate. But just keep in mind that you got to think of this in terms of 3D, but you can't really illustrate it in terms of 3D. So that's why you see the stakes that we see on the slope would be going up this slope, and they would be you would be looking at the really thin part of the stake as it goes up the slope. But we show it so we can read it facing us like this. Cut, blah, 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 all that stuff. Okay. So if I need to come back here, I will. Give me one more sheet. Ready. We may need a little bit of drawing. I don't know. I'll leave that there so maybe we can point to it. It may come in handy. Go back and forth between it and the actual module. Speaking of which, there, we're at the module. Now, let's just go through this thing. There is a, you may see where this right here, this is not what we want. This is going to be where I put this video that we're recording right now. So I don't think there's anything in there right now. If there is, and you're not in this week right now, you're in the week 6 before which is the grading a cut slope. Yeah, right after the midterm. I'll get those midterms graded here pretty soon. So let's stay with slope stakes and reference points. This is what I want you to know before we go to either Oklahoma City or Georgia for our 3-day internship. Again, those dates are March 2nd, 3rd, and 4th. That'll be a Thursday, Friday, and Saturday that we will be either, depending on which campus you're assigned to. I may only have one Okie assignment, but that's okay. Jay will take care of the rest of you guys. Some of you may remember him. He'll be down in Georgia. If not, he will have one of his instructors down there. So let's get going here. The overview is, we might as well just take a peek at that. Simple. Demonstrate an understanding of transferring information from a drawing to a stake marking. Now, we're not really going to the drawing, But we are going to know how to determine the difference in single line and double line staking. That is what the focus will be here. And I won't even talk about it till we get to it. So you will see, we will talk about transferring information from drawings to both single line and double line stake marking. And actually we will be going in the opposite direction. We'll be building, we'll be looking at a stake, but we will be looking at what the stake is illustrating or is saying. So we will kind of be looking at the plan and building a stake from that. You'll see. So let me try to get back. I don't think that's an easy way back. Maybe. Oh, there it is. And week 7. And we looked at that overview. This is the video, and it's not the one I want. It's the one that I will put in here after I get through making it, which is right now. Here, I think this is your reading material, which we want to really go into. And I'll probably do a lot of reading here, but let's do the visual first. Let's see what we're going to be talking about. We're going to talk about original. Here's the original ground. If you're following my newly colored arrow, all the way down, this is all original ground. Now, this is the top, and here's the offset stake. Now, the top offset stake would tell you where to put this, your slope, this will be your reference point to slope stake. This will be where you'll put your top stake. Here's some a couple of items that we've probably seen, and I've mentioned them, but the hinge point is the point at the outer edge of the shoulder where the road bed intersects with the side slope. And this also is the ditch or the flow line of the ditch, but this would be also a hinge point going down to the ditch and then back up. So starting up here, we have a 1.5 to 1 slope that goes down all the way to the ditch. So the slope stake, after it tells us, same information is on this reference stake, is on this top stake. For the most part, it's just, this is set out of the way. So the first thing it's going to tell us is if we go from top to bottom, it's going to be cut something at 1.5 to 1, and that cutting that 1.5 will tell us what that cut is. And we also will have our horizontal from that, just that information. And there'll also be another cut to the ditch. Will have its own little section on the stake telling us how to go down to the bottom of the ditch. See, this stops at a little hinge point right here, little shoulder on the outside, on the back slope before you go down in the ditch. And here's the ditch. And again, think of this in terms of a road going this way, back like this, with these shoulders going this way. This all, I can look at this and tell you this is all going to be cut, right? And that cut's going to be pushed down here because this is all going to be filled right down here. I can already see that. So we got from here to here. Now, if we stay, and we would probably stay with this offset because it'd be an offset or information stake or reference to point to slope stake on each side of the proposed roadway. That would be a cross section. So this stake would tell us how to get all the way to the ditch, up to the shoulder, and to the center line. This one would tell us how to fill up to where we want a hinge point and all the way to the center line. So now let's read up here. In the performance of your duties as a grade checker, it becomes necessary to mark lath with more complex information than simple cut or fill dimensions or slope ratios. It's your job to determine the correct information and then write it on lath in a manner that is useful to construct a project. And each cross section is a project. The whole project is a highway, I suppose. The following 12 pages will help you accomplish that. Figure 86 depicts a simple roadway and a labeling of the general information with respect to required slope stake information. Two terms may be new, so they are abbreviated and defined. This one was hinge point, and the flow line is right here at the bottom of the ditch. A flow line of a pipe or a ditch is the bottom elevation of that ditch. So we got the hinge points where the proposed road slope or road meets the original ground, or the point of another surface that's to be prepared, such as a property line. Like this may have come up here, and then they want this to be a certain thing. That would be another hinge point. But in this case, it's just the top. It's really not a hinge point. So single and double line slope stakes. Now this is going to get a little bit confusing. Slope stakes are written in two distinct forms depending on personal preference, or surveyors or owners or whoever's preference. The two methods are known as single line and double line methods. There is a great difference in the two, and you need to learn how to read each method at a glance. Characteristics of a single line method: all horizontal, this is important, all horizontal and vertical data, dimensions to me, are from the toe or the top. In other words, all the information from, let's go back here, will come from here. Like whatever this horizontal is, it will be measured from this point. Whatever this slope is, and for the same thing here, this will be your reference. When we go to double line, it will change to here, and one will be measured and from the here to here, and then this next measurement would be from here to here. So each component or the hinge point, or wherever you are, like you may very well in double line measure this slope from here, and if it's a filled 3 foot at 3 to 1, that would be 9 foot, would be half the width of that ditch. But we'll get further into that. Let's see where I stop. Characteristics of single line methods: all horizontal and vertical data from the toe or top stake, from your first stake, not above toe or below toe, top. Double line method is each step is relative to the preceding step. In other words, just like I said up here, if I'm going single line, everything is measured from this stake right here. If I'm going double line, I may measure to the ditch horizontally and vertically to the ditch from here, and I can put a double line and then fill whatever it takes to get a 3 to 1 to here. And then from here, it may be level or 2% rise, plus 2%. This has a minus 2% going across. But you measure from your last known point to it's a little bit like differential leveling. We establish points as we go along, and then we turn around and measure back from that point. But again, single line, everything would be measured from the same point. If you've ever if you wanted to, say you have a 2x4 and you want 20 pieces 2 foot long of 2x4, So you cut you one piece and it measures 2x4. So you start using that as a gauge. Well, you're going to accumulate any errors and it'll keep accumulating and accumulating. If you come back to the same point, your measurements are going to be more accurate because you're measuring from the same point every time. Now, a lot of surveyors will make you do this on a highway or something like that. That's real, the standards are really tight. Double line is the easiest and quickest way, and for the most part, that's what contractors want to do. So the difference will become obvious when comparing the two methods from the examples in the following. In figure 87, the fill to the hinge point is 5 foot. Where's 87? Right here. It's this, the fill to the, I lost my place. Oh, there it is. The fill to the hinge point is 5 foot from the toe. So from here, if it's 3-to-1, and if it's a 5 foot vertical, what's the horizontal? So we'll go out 15 and we'll go up 5 from here. And here's the two stakes. Say we're using this stake right here. This stake and this stake are different. But let's take a look at this. Let's look at the single line first. Fill 5 foot at 3-to-1 to the hinge point. No double line here, right? The next thing is fill 5-4 at 35 to the toe. So let's look at that. Let's take this. We got to set our. We're going to the hinge point first. So we're going to take this toe stake right here, this toe stake right here, and we're going to go out 15 feet because it says it's a 3-to-1 slope, and it has a 10 foot right there. Is where your vertical is. Vertical. So we'll go out, up to the hinge point. Now, let's look at the double line one. We need to be in the, and then the center line is, let's look at it. Fill 5-4 at 35 feet to the center line. Where did 35? Where did 35? Where did this come from? Look at this. Fill 5 feet to the center line. Well, let's look at this. Let's start adding up some things. Here is 15 feet. Here is 35 feet. So there's our horizontal right there at 35. Where is our vertical? Right here. 5-4. So we're going to this point right here, to the center line. But look at this 2%. Now where did that come from? Well, let's look at this. Here is 5 feet, and here is 5.4 feet. 5.4 feet. So give me a minute here. I mean, don't go nowhere. This is 5.4 feet. So this point is 0.4 feet higher than this hinge point, is it? So it automatically has a 2% rise, or plus grade, going from the hinge to the center line, and that's a very common cross slope in there. So where did that come from? How do you calculate percentage? You take 2%, look at 20, look at 0.4 divided by 20. Take this 0.4, let me do that. I'm going to take that 0.4, 0.4. I'm going to divide it by the horizontal of 20. We just saw this on a drawing. So that's where we got the horizontal. And this we saw on the drawing. That's where the 0.4 came in. So that is 0.4 divided by 20 equals 0.02. Multiplied times 100 is what? 2%. So this stake took us to this point right here, and it included a 2% rise if you're going from here to there. Now let's go to the double line. Same information to the hinge point, right? So we get this. It's 3 to 1. It's a field of 5 foot, so it's 15 feet right there. That gets us to the hinge point. That's exactly what's here. But this one says, and then from this point, fill 0.4 feet. So there's our vertical that we got to build. At 20 feet, our horizontal. So again, that gives us a 2% 2% rise in elevation for the cross slope, and that's what we want. Look at these two states. This information and this information look different, are different, but it takes us to the same place. This is just doesn't have an indent. This has to be measured. Everything is measured here from here. That's why it's 35 feet out, and this is 20 feet out, because it's measured from your last known point. It's 20 feet over. Hope you get that. So on a single or double line, the first data is the same. This data is pretty much the same on single and double. But all subsequent data are different. You will find that this data changed right here compared to this data. On the single line, all data are from the slope stake, while on the double line, each data follows the preceding step. Double line means literally and then. Let's examine another situation whereby the slope stake, the top is written in both forms for comparison. Please refer to figure 80A. Here we have two stakes saying the same thing, just saying it differently. Let's start with the single line once again. It says cut 10 feet at 1.5 to 1. So I'm assuming we start here. It's a top, it's a cut slope. So we're going to cut 10 feet. There's that. And we're going to do it at a 1.5 to 1 ratio. So 10 times 1.5. Do you see where the 10 comes from now? If you don't get this thing, you're in trouble. So understand these ratios. I can use all of these things. This is a percent of slope, and it could be a ratio right there. So right now we're dealing with percentages, most likely, for this roadway. But the slope is 3 to 1. So that will come in handy also. Now, I said let's start at the is that the one we just did? Yeah. Let's start with the double line, cut 10 feet at 1.5 to 1. That gives us 15 foot horizontal and 10 foot cut. That puts us right here at this bench. That's what that's called, this little guy going out. And sometimes they'll go up a little bit, but we'll see. So for right now, we're going down 10 and over 15. That takes us to here. Let's see what this this does. Cut same information, right? So let's go a little further here. Let's stay with the single line. Cut 10 feet at 25. So I'm going to cut 10 feet at 25. So my horizontal is 25. Oh, we're going to the same bench. Cut 10 feet at 1.5 to 1. All right. Level for 10 feet and then level. Over here, instead of and then level, that's telling us level 10 feet. That's taking us all the way to 25. And then level takes us to right here. This says cut 10 feet at 25. So that's 10 down, 15, and another 10 is 25. So both stakes, even though they look different, they took us to the same place. Let's see what we do to get down here. This will be the, this was the bench. This is to get us to the bench. This is to get us to probably here. This is our next deal, which is a hinge point. So let's see what it says. It says, this is going to be interesting. This also says cut 10 feet. It says it again. This one said level. But let's stick with this. It says cut 10 feet at 25. Take us out here, 15, 25. Puts us at the same location. It would be like 10 feet at 25, even if this was solid, just one slope. But to get this bench in here, it has to say cut 10 feet at 25, and the cut 10 feet keeps us with the cut 10 feet in both places. We cut 10 here, and we cut 10 here, even though there was no ground to cut. Next one. And then level. And this puts us to the same point at level because it's cut 10 feet. And this is already cut 10 feet and then level for 10 feet. Now let's see where this one right here takes us. This is taking us to this hinge point. But we still got to go all the way back here. Cut 16 feet at 34. Well, let's just quickly see where 34 takes us. There's 15, there's 25, and there's 9. 34 takes us here. There's our horizontal right there. It takes us to this point. And it also has a, what did I say? 25 and 9, 34. Takes us here. It also has a 16-foot cut. Well, let's see where that came from. Here's 6 foot of it. Here's 10 foot. So we went down 16 and we went over 34, which puts us right here. Let's see what the and then stake tells us to do. And then that means we're starting here. And then cut 6 feet right here at 1.5 to 1. So what's 6 feet at 1.5 to 1? 9 feet. That puts us right over here in the same hinge point, same place. This took us to here, and this took us to here. Back to, now we got to get to this here center line. This will be interesting also. We got to go back. We're going to single line. We got to go back here. And the first thing we're going to do is cut 15 and 7/10. No, let's don't. Let's find horizontal and see what's there. This is at 44. So here's 15. Here's 25. and here's 9, that's 34, and here's 10, that's 44. And look where we are. Now let's see what this cut does for us at 44. Cut 15/7, where's that going to come from? Here's 10, here's 16, but look, we got to go up 0.3 to get to this 44. So look what this is saying. This is a 3% rise over 10%. So it's telling us, it's giving us the thing. This right here tells us to be 3/10 higher. It just gave it to us here. But with that 3% rise over the horizontal distance of 10%, we would have the, let's see, 0.03 times 10 equal, didn't turn it on, sorry, 0.03 times 10 equals 0.3. So it all adds up. 3% is the same as 0.3 higher. So that put us at 44, and it put us at the center line, which is 44 feet. And it put us at a cut from there of 16 feet. No, here, 15/7. 15/7 to right there. Because remember, we came down to 16 here, and we want to be at 15/7. So the rise tells us, puts us at 15/7. That's where that point is. It's 15.7 feet lower than this point right here. Now let's use the and then one. Look, all it says is fill. After we get to the hinge point, it just says well, did we calculate this hinge point? I think we did. Let's make sure. Cut 6 feet. So let's see. We're going to go down. Here's 10 feet. But we only want, from here. I'm sorry. That's right. We want to go down 6 feet and at 1.5 to 1. So that's going to put us 9 foot over. That put us there. So this one has us also here, but we want to get to the center line. Well, it's simple. Fill 3/10 fill 3/10 at 10 foot. That's at 3%. Again, that brings us up here. That's a really good, no, I won't call it simple, but I want you to understand that we're actually taking just some pretty standard dimensions. We're given a slope in a couple of places, but we really don't need it. It just turns out that 9 horizontal and 6 vertical is a 1.5 to 1 slope. That's what they wanted. They just gave us the actual dimensions. Same thing here. They wanted 3% fall on this shoulder or whatever from the center line on this side. They wanted 3%. So the way they gave it to us is like this 15/7 took us down to here, and it adds up to 16 here. So that leaves us 3/10 over 10 feet, and that gave us that 3%.